Hey everybody, what I'm going to do in these videos is these videos are mostly review for many of you, and what I want to do with these videos is show you a process of how to do one-step equations with, just basically some sort of, like I said, a process looking at it, like how to get things by itself and how to solve for your variable. So just some terminology we're going to need to know, some vocab, is our variable is always going to be our letter in the equation. And then whenever you have a number by itself, like this 8 or this 15, those are called constants. So that kind of information, we're going to need to remember what that is when I'm doing that. And the first kind of equations we're going to look at are equations where you have a variable. The variable is always going to have a coefficient of 1. All right, that's why these are one-step equations, because I won't have to do anything else to get rid of that, at least in the addition and the subtraction problems that we're going to be doing. So you've got a coefficient of 1. They don't usually write the 1. And in these problems, in this video, something's being added to it. And so what I want you to think about as we start looking at our first example here of x plus 3 equals 26 is, what do I have to do to get the x by itself? And the answer in algebra is always, you have a balanced equation. So I like to kind of think of, let me do this here. I like to think of, well, imagine you've got like this teeter-totter here, right? And there's this fulcrum here, and then you've got this x plus 3 over here on one side of the teeter-totter, and you've got this 26 over here on the other side. And because they're equal, they're balanced. And that means, one side's not going down, while the other one's going up. We don't have that happening here because they're balanced. But what's going to happen if I want to get this x by itself is I'm going to have to take this 3, this plus 3, and I'm going to have to, get rid of it somewhere, kick it off somehow, and I don't know what I'm going to do with it. So what we do in algebra is we move it to the other side. And the way we move it to the other side is, if it's being added, then we're going to say, okay, well, if the 3 is being added, we're going to subtract the 3. But what's going to happen is, because I'm taking 3 away from this side, that means this side's going to be, in a sense, lighter, and that, and then you don't have a balanced equation. So whatever we do to here, think about what you would do if you were on a teeter-totter and maybe there were 4 of you on the teeter-totter, right? And 3 of them tried to get off. You have 4 people on each side. So let's draw a little picture here. So if I've got a really big teeter-totter, right? Now I've got 4 people on one side. And then I've got the same thing going on over here. Sorry, I'm getting impatient drawing this. And I said, okay, I want to take these 3 people and get them off the teeter-totter, but I want the teeter-totter to stay balanced. Well, in order for that to happen, we're going to have to take another 3 people from the other side of the teeter-totter, and they're going to have to go. So that's the whole concept here is, all right, let's get back to this this problem here, and then I think some of this will start to make sense to you guys. So that should be good enough here for us. Is I've got x plus 3 equals 26. Well, I want x to be by itself. So if I want x to be by itself, what I'm going to have to do is I'm going to have to get rid of this 3 that's here. So I'm going to get rid of it by doing the opposite to it. If it's being added, which it is, I'm then going to subtract it. So I subtract 3 here. I'm going to subtract 3 from here. Okay, and the reason I'm doing it to the other side, and usually when I set these problems up, I put a fence up. And when I subtract it from the other side, what happens is, if you have positive 3 and you subtract 3 from it, the goal is to get that to go to 0. And it does go to 0. All right, good. This goes to 0. And then you're just left with x over on this other side. And then you just simplify this side. 26 minus 3 gives you 23. This is a simple enough concept, but it's hard enough that people don't always remember, oh, do I add, do I subtract? So the big thing I try to teach is just always do the opposite. Always do the opposite. If you can think of opposites with algebra, you're going to be in okay shape. And you will see how that works more and more as we do more of these problems. So let's look at this one here. Same thing. Y plus 78. I want to get y by itself. I want this to be down here where y is by itself and it's equal to something. Well, in order to do that, I'm going to have to get rid of that 78. So I'm going to get rid of it by doing the opposite. So I'm going to subtract it, and that will give me 0 over here. And then I'm going to subtract 78 from the other side. So whatever, you can do whatever you want to this side of the equation, but you have to do the exact same thing to the other side. So that's the other, fundamental rule of algebra, is that you can do what you want to one side, but you do it to basically the whole equation. So 145 minus 78, if I simplify that, that gives me 7. This becomes 13 minus 7, which gives me y equals 67. You can always take this number and put it back into your equation, 67 plus 78, and see if that equals my 145. And if you do it, it sure does. All right, let's try another one. R plus 5 equals 3. All right, so with these problems, it's the same thing. We're going to set up our fence, and we're going to try and get r by itself. So we're going to subtract 5 from both sides. And this is where I can start to see people, who aren't comfortable with positive and negative numbers start to get confused. And then weird things start to happen, like they'll get 8 or they'll get 2 or something weird's happening. So what I like to do is I like to think of it, you're on a number line, right? And if you're at 3, at the point 3, and you're taking away 5, that basically means you're going to the left 5 spaces. So you're going 1, 2, 3, 4, 5. And if you think about what a number line looks like, it will go 3, 2, 1, 0, and then the numbers start to go up in the negative direction. Well, technically they're going down, but we think of it as going up because it looks like it. So r would equal -2. So 3 minus 5 is -2. And then for our last equation, p plus 12 equals -4. Same kind of problem. We're going to subtract 12 from both sides. And the trick I always try to teach people is whenever you have two negative numbers and essentially you're adding them, you can think about it that way. So -4 and -12 is basically just add the numbers up. So 4 plus 12 is 16, and then keep the common sign. And the common sign in this case is negative. So there's a lot going on here, a lot with these numbers that you're going to have to really, start paying attention to. A lot with positives and negatives, a lot with, opposites and all of that. So a lot to keep track of, and we're gonna do our best to do that. So thanks for watching the video. It's a little bit on the long side, but it's just getting us kind of started on this algebraic journey that we're going to be on.